Welcome to the NIHR Dementia Researcher podcast, brought to you by dementiaresearcher.nihr.ac.uk in association with Alzheimer's Research UK and Alzheimer's Society, supporting early career dementia researchers across the world.
Welcome to the Dementia podcast, bringing together career researchers and leaders from the field to discuss their research, hot topics, and share tips about careers and career progression. My name is Nicholas Ashton. I'm from the University of Gothenburg, and it's my pleasure to be guest hosting this exciting podcast about biomarkers. And we will mainly be discussing about blood biomarkers today and their incredible advancement in the last few years. So let's meet our guests. So we have two, I would say, of the experts in the world of biomarkers, not just fluid biomarkers, but also imaging as well. So we have Professor Oskar Hansen, a Professor of Neurology at Lund University and the PI of the Biofinder study. And we have Professor Henrik Zetterberg, who's a Professor of Neurochemistry in Gothenburg and several places around the world, spanning many continents. So it's a pleasure to have you both here. Thanks for accepting the task of putting up with me as a host. This is the first time I've ever hosted anything in my life, so we'll see how it goes. So for many people many people do know you guys, but for those that maybe don't, Oskar, do you just want to explain in a nutshell your work and your research?
Yes, sure. So, as I said, I'm a professor of neurology, always been very interested in neurodegenerative disorders. Started out with Huntington and Parkinson's diseases, but then got more and more interest in Alzheimer's disease. And just as you said, I've been working quite a lot with fluid biomarkers together with Henrik and Kai and so on, but also MRI and PET imaging, especially in the last 10 years. So, I guess that in short is me.
And Henrik?
Yes, I am. I started in this research world 20 years ago now, and my clinical training is as a clinical chemist. So I am a laboratory specialist. That's my sort of medical specialty. And when I did my residency in clinical chemistry, I got to meet Kai Blenov, who came. He was also working as a clinical chemist here in Gothenburg, and he came to our research group to learn how to clone genes. I did studies in molecular biology, more specifically how Epstein-Barr virus can transform lymphocytes into cancer cells. And then Kai came to our research group to learn how to clone genes, and we started to discuss clinical chemistry. And the fascinating thing for me when I spoke with Kai was that in clinical chemistry as a clinical specialty, we have liver tests and cardiac markers and kidney markers and so, but then we didn't have very good markers for brain diseases in biofluids. Of course, imaging was big already then, but developing fastly. So I was thinking, we started to discuss some collaborative projects, and then I was thinking that perhaps this could be my future field. And since then I've been working with clinical neurochemistry, so that has been my subspecialty as a clinical chemist, and also done academic research here in Gothenburg and in other places in the world like London, and where I also run the UK Dementia Research Institute Fluid Biomarker Lab.
Very nice. So a lot of wealth of experience here. So as full disclosure, I work for Henrik and I work a lot with Oskar as well. So if this was a political debate, it would be banned because it's going to be the most biased blood biomarker supporting podcast you'll hear, I think. But I think it's my role to play devil's advocate today. So I'm going to pick holes in my own work and that won't be too hard, I'm sure. But I want to ask you to be honest here. This is an honesty question to start with. So let's go back 10 to 15 years ago, and you're in conferences, and me and other keen PhD students are showing this explorative blood biomarker work using mass spectrometry and different things. And we're coming up with these models where they could say it would work. To individuals that have mainly worked in CSF and PET imaging, let's say 10 years ago, did you really think that there would be a blood test for Alzheimer's disease to the level that we have currently showing in our research today?
I can simply say, I can just say no, to be honest. We had done some work together with Kai and Henrik on plasma bit for 240, and it didn't look too exciting, even though there was maybe some signal there. And of course, things could improve, but my gut feeling was very wrong. I thought that we would never get any blood test that could work to at the same accuracy as CSF biomarkers. So that was what I was thinking 10 years ago.
Mm.
And
do you
I could
agree,
also
Ellie?
I could add that I had such a big respect for the blood-brain barrier, and my view on the blood-brain barrier was that it was super tight, and I was thinking that proteins will not. It will be there are too many steps between the brain tissue and the blood for this to be successful. I must say I thought some of the. I mean, you presented some work, Nick, on complement proteins in blood. And there were also genetic associations, for example, with complement factor H, where there also seemed to be a biomarker protein concentration difference in blood. And those things I was thinking that perhaps this could be meaningful in some way. But I thought that the relationship with brain tissue changes would be much looser than we now see with these novel tests that you, Nick, and Oscar and other people have developed. I am I'm actually quite I'm positively surprised that it works so well, and I also actually think it's quite fascinating that the small amounts of proteins released from neurons in the brain eventually can be measured in the relatively large blood volume that together with a lot of other proteins that are in much higher abundance, thinking about the plasma proteins. There were also some reproducible blood biomarker signals early on. For example, transthyretin came up over and over as slightly altered in Alzheimer's disease. It is an interesting protein from an amyloidogenic perspective, but the differences were always a little bit small. And for me, it was easy to think that this is probably something systematic, some systematic difference between people with dementia or a cognitive disorder, perhaps in a pre-dementia state, and a biomarker change, rather than a direct effect of the pathological processes in the brain parenchyma and the blood proteome. But again, that was wrong. Just like Oscar said, it turned out to be wrong. The A-beta story was interesting because A-beta was possible to measure with several immunoassays, but when we tried to validate those assays in spike recovery experiments or when we checked for dilution linearity, it was quite clear that the assays didn't work that well, but they were the best we had. The spike recovery was lousy, below 50% for some of the assays, and if you diluted the sample, the signal got higher and higher, which didn't make sense either, up to a certain amount of dilution. So there were many warning signs that when we tried to measure tau and A-beta and neurofilament light with existing ELISAs and got some results, they were not very reliable until we got better assays that were more sensitive and more and could measure these proteins without a lot of matrix effects from the blood proteome.
And did you have this realization moment, this kind of where were you moment when you realized, oh, this is going to work, actually, I believe this now? Was it with neurofilament light, or was it the phospho-tau data? Or
it was the neurofilament light data. That was such a fun project. We had gotten in contact with Quanterix. Actually, Quanterix, a guy called Dave Wilson, he emailed me and Kai it was almost like a commercial email from Quanterix, a small startup company, and said that we have a new technology which allows for ultra-sensitive biomarker concentration measurements, and we noticed that you work on brain diseases, you might be interested. And then he explained the Simoa technology very briefly as a compartmentalized detection reaction based on the sandwich ELISA principle. And I was reading it and I was thinking that I see how this could work. And then we said that let's try to do some pilot experiments. We started out with tau, total tau, and then Quanterix rapidly made a total tau assay that worked in acute brain diseases. We started out with the most severe brain disease we could think about, and that was hypoxic injury following out of hospital cardiac arrest, where we thought that this would be a massive release. And it was in poor outcome patients, whereas good outcome patients released much less. So then it felt like this was working, but of course it was a bit extreme. But then we took NFL antibodies together with human diagnostics and put them onto Simoa, and it worked. That project worked in-house here with the homebrew kit. It took 4 weeks until we knew that this assay was working, and such a fast. It was those weeks were amazing in the lab when a guy called Victor Lehmann here did the experiments and could see that transferring the human diagnostics ELISA onto the single molecule array platform, achieving ultrasensitivity, would give a blood test with correlation with CSF for neurofilament light. But then I guess you must have had, both of you, Nick and Oskar, must have had quite cool experiences with the phospho-tau projects.
Oskar, do you remember when you first saw the phospho-tau results in Biofinder for the first time, for instance? Or...
Yeah, I actually do. Because that was a very specific moment, and it was actually like a revelation, to be honest. So I was actually in Stockholm to give a lecture, and you, Henrik, were actually sitting next to me, and I was just going to go up and give a talk, and then Shirina Janelidze here in my group had sent rock curves with new phospho-tau 217 in Biofinder 2. And I just opened the file, and looked at it. And when I looked at it, looked at it, this is so great. AUC is well above 0.9 with a blood marker for detecting Alzheimer's disease. I remember I showed it to you, Henrik. I just look at this. And I just almost forgot I was going to give a talk 5 minutes later. So that was actually one of those moments in my life that I even remember everything what was happening around me. So it was very special.
We had something similar in the lab. So Thomas Karikari developed the 181 assay here in our lab, and we measured the triad cohort for our first paper. We were completely blinded. So when we sent the data away, and then we had this phone call like 2 hours later from Pedro Rosanetto in Canada, who's the leader of the cohort, saying, "I'm out of a job," because he's a imaging tau imaging guy. He said, "This looks fantastic. I'm out of a job. This is amazing." So that was when, okay. So we didn't actually see any rock curves. We just had this phone call from a panicked professor over in Canada saying that he'd lost his job because there was such a good blood biomarker. So, I mean, these are the early studies. So what we're talking about here is these 2020 papers, and there were a few earlier as well, which gave a hint that this was going to work. But there were papers from the Biofinder study and here in Gothenburg and also in the US showing that this phospho-tau marker was really specific if you had Alzheimer's disease pathology. And I guess we've now moved on, and there are many studies that are replicating these findings. And now we're really talking about the details about these assays. And, there's some debate about which assay we should use and which context should we use them. But there are different contexts. So Oskar, as someone that sees patients on a more regular basis, how does now a blood test or a test for phospho-tau, for instance, impact a clinical setting? Like a patient that comes to see you now, how do you see this happening in 2 to 3 years' time? Or are you doing it now, for instance?
Yeah, so we're not yet doing it, but actually we will start in 2 months doing it in a prospective manner. And what we first will do is in our memory clinic, that is a secondary memory clinic. So still quite heterogeneous population. So the idea is to start doing this in all patients that come in, new patients from a primary care. And initially we will actually continue doing cerebrospinal fluid measurements on everyone as well. That's just a little bit to get a feeling for how well it works. But I hope that we quite quickly, at least within 1 year, can stop doing CSF in the huge majority of individuals. So what I'm hoping for, depending on how accurate the test will show out to be, this will be phospho-tau 217, is that maybe those with very low levels of phospho-tau in blood, they will be negative in the huge majority on CSF, so we don't need to do any CSF. And then we have those with very high levels, and hopefully they will be to a large degree also positive on CSF above maybe 90%. But then we will have people that are very close to the cutoff, maybe 10, 20, maybe 30% of the patients, where I still think that we will probably do cerebrospinal fluid measurements. This will still be, I guess, dependent on if there will be disease-modifying therapies around, because then, of course, it's even more important to prove that the patient had amyloid pathology in the brain. So then we might be even more cautious and maybe do CSF still in everyone before we start such a treatment. But I think we need to see some of the new assays that have been developed for phospho-tau show such high accuracies that maybe in the future we will not need to do that before starting a seismoid therapy. I think that would be the dream, and also will make it much easier for clinics that do not do lumbar puncture as our clinic do. So that is my goal, my dream. But also, of course, use in primary care. But that will take a little bit more time, I think. We need to evaluate it a little bit more closely. I don't know what you think, Henrik.
No, I agree with all what you said here, Oscar. So I work in a clinical lab, and in Sweden it's so fortunate because we have the possibility of taking research grade assays and validate them for clinical use. We can do that as clinical chemists, and then we do it according to standard operating procedures, and then we are of course also examined by accreditation bodies in Sweden. One of those bodies are called it's called SWEDAC. And then we sort of put our license to practice on the table. That's sort of how it works. But we have not yet. We are still making up our minds exactly on what phospho-tau form to go for in clinical practice. And in clinical practice, it's a little bit more complicated than in research studies, because in clinical practice, you have to be able to run the assay week by week and maintain stability in your measurements in relation to the studies where you establish the reference limits and cut points. And you monitor this with internal control samples, and there you can see if you start to drift a little bit. But if the drift needed for giving a systematic effect on the diagnostic accuracy, if that drift is small, if the difference between cases and controls, for example, is relatively small, then it can be very tricky to maintain the assay in a good enough shape for clinical practice. So we have to look at the fold change, and we have to look at the analytical variation, and we also have to look at biological factors and the variability of the biomarker. And if I would start to discuss these biomarkers from these aspects, biological variability is relatively low for phospho-tau, super low for the A-beta 42/40 ratio. It's amazingly low for that ratio. And confounding factors seem to be a little bit lower, the influence of such factors on A-beta 42/40 than on phospho-tau. But the difference between cases and controls, amyloid positive individuals and negative individuals for A-beta 42/40 is really small compared with phospho-tau. So there are pros and cons with these markers, and most of the pros lean towards the phospho-tau tests over A-beta 42/40, but exactly which phospho-tau form one should pick is still a little bit open, although phospho-tau 217 often looks a little bit better than the other ones, but it is a little bit harder to measure. So that is sort of the clinical chemist's viewpoint on this issue. But we hope to be able to be up and running in clinical practice, in clinical laboratory practice during the spring, in parallel with the study Oscar mentioned, also to prepare, in this case, Sweden and neighboring countries. And we can also potentially help Northern Europe if needed for the advent of disease-modifying treatments. And there are many other groups that also work on this. So I think we will see a quite rapid development of these blood tests into clinical laboratory practice. And they are actually already up and running in some of the US labs. A neurofilament light we have done in clinical chemistry routine in our lab and in several European labs for more than 2 years now. So it's going fast. But of course one needs to think about what these biomarker results mean and keep the mindset that the biochemical test in itself will never be diagnostic. It has to be interpreted with a clinical picture, with other examinations, and it will be exciting to be a memory clinic doctor in the future, I'm sure, because there will be even more interesting tests one can do on the patients, including cognitive tests and imaging and blood tests, and when needed, CSF.
And I think that the aspect about clinical routine and therapeutic trials, and I think it's very translatable. But I also think for researchers that are listening here that maybe not in biomarker work, they can use these tests in their own research. This is a cheap way to say that you're maybe it's an inflammation drug that you're studying, or a different, completely different profile that. You can use these blood tests to dichotomize patients in a cheap way that when you didn't have CSF and imaging imaging biomarkers. So I think this is useful for not only in clinics and therapeutic trials, but us as researchers to use these tests in our day-to-day research pattern. I just want to go onto a point here about you, Oscar, Henrik, that you said about clinical symptoms. Now, I often try to communicate this in my talks, that phosphorylated tau does not mean Alzheimer's disease dementia. It means Alzheimer's disease pathology. So I don't know, Oscar, if you want to explain what you think phosphorylated tau is reflecting on the biological level. Is it amyloid? Is it tau? Is it... I mean, I guess that you've done a lot of research to say that the correlation but with symptoms is quite weak, I would say. It's not perfect. It reflects more the biology that's going in the brain rather than the symptoms that someone exhibits, for instance.
Yeah. No, so to me, I guess phospho-tau is reflecting amyloid-induced hyperphosphorylation and secretion of tau. So it's something very connected to the amyloid pathology in the brain, but still it's not just reflecting the amount of plaques, because we still see not a perfect correlation either between the number of plaques and the phospho-tau levels. And it's slightly different between the different phospho-tau species that we have looked into yet. Now, so some are definitely more associated with tau tangle load than others are. So I think we need to be a bit careful there, or not using just the word phospho-tau, but actually, for example, 217 seems to be more related to tangle pathology maybe than 231, and maybe there are others like 205 and so on that are even more related to tangle pathology. So I think in the future we will know much more of that when it comes to that. But I also want really to reinforce what Henrik said, because as a clinician, we've been working with CSF in our clinic for maybe 20 years, and we always look at the results in the context of the symptomatology of each patient. So it's not unrare, no, or it's not rare. I mean, that a patient with clear FTD, for example, also have some amyloid pathology in the brain. And when we have done a tau PET scan, for example, that is usually negative, and we know that this individual have probably free R-tau or TDP in the brain, and also some amyloid, but it's not the amyloid causing the symptoms. So I really think that the clinicians still need to think about this and not just look at the test, just as Henrik said, because that will be important. Because removing, I guess, amyloid in the brain of a person with actually FTD pathology driving symptomatology will not be so helpful. So there is maybe some role for tau PET imaging that is much more associated with the symptomatology of a patient. Not only the load, as you know, also the region where that tau is, if that fits very well with the symptomatology, you know it's Alzheimer's disease. But I still hope that in the future we can solve that with more tau tangle related markers. So we can look at the level of these markers and say that this individual have a lot of tau in the brain, so it must be related to that patient's symptomatology. So
I think it's really very clear to we're not invented something new here. We should treat blood tests as we would do with CSF tests. It just means that it's easier to get tests to more people. Essentially, is what we're trying to communicate.
Yes, but also still optimistic with all these new tau isoforms that you and others are now developing assays for that might be more related to the tau tangle pathology when we normally measure in CSF. I think that could be helpful here actually. So we do not need to do tau PET imaging in these cases where we feel a bit more uncertain if AD pathology is actually driving the pathology or the symptomatology.
I could also add that when we talk about the different phospho-tau forms, again, thinking about the clinical laboratory practice situation, it's really nice when you are a clinical chemist and look at data and the things do not really fit. It's good that there are other assays around, because then I can call a colleague in another lab and ask them, could you help us doing a measurement with your assay on this particular sample where we are uncertain about perhaps it's an unusually high level that pops up in an individual where it's unexpected somehow. So therefore, I again am very much for this view that we work in this field together, developing different assays that might give slightly different associations with brain pathology in different disease stages, and they could complement each other. And in CSF, we have had this fortune in the Alzheimer diagnostics field to look at total tau, phospho-tau, A-beta 42, and A-beta 40, and particularly looking at A-beta 42-40 ratio. And then this becomes a pattern. And if one biomarker is a little bit off, we would never draw any too strong conclusions on that. If all three are positive, it really indicates that something is going on, although one can never exclude that this is preclinical Alzheimer's disease, and that there is something else that is causing the patient's symptoms. So this is it sort of reiterates what you just said here now, that the biomarkers have to be interpreted humbly and as markers of brain changes, but not as markers that explain the whole situation for a patient. I'm also thinking about the different diagnostic modalities we have at hand with CSF and advanced imaging also. And then I remind myself about, again, the hepatologist's view on liver disease. So perhaps a primary care physician notices liver enzymes that are a little bit up. They discuss alcohol, they discuss some other things. The enzymes are still abnormal, and then eventually the patient is referred for evaluation at a specialty clinic. And then the hepatologist has a host of different things he or she can do. And that spans from ultrasonography and some different examinations of the biliary ducts. And then eventually he or she might even do a liver biopsy and look in the tissue. So, I mean, we have, I really think we should have that mindset also for these new biomarkers and look at them as clinical chemistry tests for brain diseases with all the pros and cons that, or strengths and limitations that exist for these biomarkers. And when one compares the diagnostic performance of these biomarkers that we are discussing now with other clinical chemistry tests, they are top tests. They are really, really good. The diagnostic performance of some of the kidney biomarkers we use a lot, or the, again, liver disease tests, and also some of the cardiac biomarkers are, they have similar AUCs as the ones we have at hand. But one needs to always keep limitations and so in mind. Thyroid hormones is the same also. There we have really seen some analytical problems throughout years, and they have been solved more and more. But there are also effects of general somatic disease on thyroid hormone levels, and these could be regarded as confounders, although it also could have to do with how the thyroid is regulating the metabolism in the body in general. So there are lots of things to consider and discover when we now go for more broad scale use of these biomarkers in contexts where we perhaps wouldn't have used them before also, because they will be more easily accessible. This is where the primary care study will be super interesting, Oscar, when perhaps some individuals with relatively mild symptoms and a lot of other problems will be tested. Then that will of course challenge the biomarkers the most.
So let me ask this question. So this fits quite nicely into this. We had a lot of questions, but this one stood out. This is from Eddie Ricatti, and he is doing research in Tasmania, by looks like it. He wanted to ask a question about clinical cutoffs for blood biomarkers. So this is his question. Will there be a one-size-fits-all cutoff for these tests? There will be some maybe things about round robins and certified reference materials. Henrik wants to maybe comment on about that. Will age, sex, and genetic ApoE tests have an influence on these results? Will they factor in at all? That was the second part. And the third part, would it be more useful to look at someone's intra-individual change as a marker rather than their cutoff for the whole population? So if someone increases by 20, 30% over a year, would that be more useful or more interpretable than? What if someone's baseline level phospho-tau is different to someone else's? Would the increase be more useful? So there's three, I thought, really nice questions. I don't know who wants to start with those.
I can maybe just start quite briefly, and you can fill in. As a physician, now I'm not a chemist, so as a physician, I don't have a problem that there are different cutoffs for different tests, to be honest, because there's so many different tests. And as a primary care physician, you will probably order, let's say, a phospho-tau test maybe 10 times a year or something, and you will anyway not remember the cutoff. So as long as the laboratory provides the cutoff to you, that would be fine. Henrik can explain more if it's important from a chemist perspective to have the same cutoff, but from a physician, I don't really see that that is needed. When it comes to adjustment for sex and age and APOE, when it comes to phospho-tau and Aβ42/40, I don't see that either, because they are so tightly associated with the AD pathology in the brain. And if you have a high-performing test, I don't see why the cutoff should vary with these demographic variables. I think it will be the same cutoff independent of these. Of course, it's more common with AD pathology the older you are, and more common if you have an APOE4, if you're an APOE4 carrier. But the cutoff should be the same to me, so it shouldn't make a difference. The last with change over time, I guess, is only interesting in those that have values very close to the cutoff, or I guess just below the cutoff. Still, we know that these tests, Aβ42/40, phospho-taus, at least with phospho-taus we've been talking about today, changed maybe 10 years before clinical onset. So if a patient comes in and have symptoms, it should already be abnormal. But still, if you have a test result close to the cutoff, I, as a physician, would probably ask a patient to come in 3 months later, and I would take a new test and I would see, okay, is it now clearly elevated or not? But that's maybe more retest variability, more than change over time, I guess. It might be different, I guess, if we have a marker that is more tangle related, that we assume is changing more during the symptomatic phase of the disease. And it might also be different if we are thinking about pre-symptomatic Alzheimer's disease, which is maybe not what we're thinking about use of now in clinical practice.
No, I agree completely with everything you said here, Oscar. There is actually one example of a test where it really helped to sort of normalize for inter-individual differences in biomarker release, and that was CSF-Aβ42. So once this was something that Piotr Levchuk in Erlangen talked about a lot already in 2006, I think, and we were so tired of him talking about this ratio because it was so he really advocated for the use of Aβ42 over 40 compared with Aβ42 alone. But then I felt it was a bit confusing because Aβ40 was not systematically changed in Alzheimer's disease. But everything was explained when you put Aβ42 concentrations on the y-axis and Aβ40 on the x-axis, because then you see that people with amyloid pathology, they have a different correlation between Aβ42 and 40 compared with people without, and that really made the separation between the groups much better. So when we started to use Aβ42 over 40, we could normalize for this inter-individual difference. We still do not understand that inter-individual difference, why some are sort of low producers and some are high producers, and those who are low producers but amyloid negative, they are closer to the cut point for amyloid positivity. So they will more rapidly go below that cut point and become biomarker positive, CSF biomarker positive for amyloid. But then again, the ratio corrects for this. For phospho-tau, I think I also think that the disease association, at least in symptomatic disease, is so high that we won't need to do these things. There are some groups that speak for doing a type of ratio, which, for example, Randy Bateman's team in St. Louis with the occupancy ratio, a bit when his team compares phosphorylated and non-phosphorylated fragments of tau. And it's really interesting, and it might be good, but in blood there is always a risk that one starts to measure peripheral big tau also with that approach. But I think we should keep an open mind and see what eventually turns out to be the best. Change over time, I like it a lot from this perspective. If I know that I have family that I have Alzheimer's disease in my family and would go and check my biomarker levels every second year at my GP's office, of course it would be quite cool if we could define clinically relevant delta change where one could consider start of treatment, and that delta change could be that delta change in itself might not have to be related to a cut-off for diagnostic positivity, sort of. But I think the studies that are planned now, both in your place, Oscar, and in some US centers, will reveal if this will be possible or not, or a viable, or viable, but a clinically meaningful way forward also. It would put less pressure on us establishing good reference limits and cut points if this delta change could turn out to be of value. And then if I should now I move back to the first question, if I should just address this thing with universal cutoffs, they are impossible without a really good reference standard. And this is really, again, core standardization in clinical chemistry. So then one would have, like the meter in Paris, one would have a defined set of samples stored at very nice conditions in multiple aliquots that would last over 10 years for kit vendors to be able to use them to calibrate their calibrators, sort of. For example, a phospho-tau 181 reference material. It could be plasma with spiked in CSF or plasma with spiked in peptides that cover the 181 phosphorylated site and some other parts of tau so that the assay will work. They can be created in different ways. It's quite a lot of job or work behind these reference materials. You have to have a really good reference method to value assign the reference materials. Most likely the different phosphoforms will have to have phosphosite-specific reference materials. So one could ask, is it worth the effort? And perhaps, at least for now, it would be fine with laboratory-specific cut points. But then the laboratories, they have to establish their cut points in a good clinical material. And if they can't, and then maintain their measurement stability over time in relation to those experiments, that's really important. If the laboratory as such can't do that, then the laboratory has to approach a companion laboratory that has such data and or collaborate, of course, and get access to samples through which they can validate their cut points. But they somehow each laboratory then has to validate their level of measurement to be able to import reference limits and standards, and that is a little bit that can be hard work instead of having the possibility of relying on the clinical chemistry companies and reference materials and full standardization. The advantage with full standardization, of course, is that one could compare results on a global scale, and one could even do epidemiological studies around the globe and look at prevalence of phospho-tau positivity at the different continents, for example, and relate to genotype information and exposure data and a lot of interesting things. It's also easier to interpret clinical trials if there had been fully standardized tests. Then one could directly compare the percent reduction of a certain anti-amyloid antibody with another anti-amyloid antibody. And so there are advantages with full standardization, that's for sure. But I still wonder if it would be worth the effort now. What we need to do is to firstly finalize the standardization projects for total tau and phospho-tau 181 for the CSF tests, the most available tests. But then I think the International Federation of Clinical Chemistry and Laboratory Medicine might take on one or two phospho-tau markers, especially if the drugs become available clinically.
We have very good assays in CSF, and we all use different cutoffs. We always use different assays. And I think the advantage, of course, of CSF is they all work great. One of the maybe disadvantages of plasma is that we have quite a range of performances of phospho-tau assays in blood. We've done some studies in Gothenburg, in Lund. You've also done similar things, showing that the choice of assay that you use or the choice of biomarker you choose is very, very important here. Our first generation assays were excellent in showing that this was a proof of principle, this is going to work, but our newer assays are the ones that are more likely to be in clinic, I think. And this is where I think that maybe not standardization, but at least a consensus in the biomarker field would be more useful to say, okay, well, these are the top assays that we recommend you to use in the lab because they give us the best diagnostic performance, I think would be most useful. We are running out of time, but I want to ask you these quick fire questions because I think some are interesting and I want to know some of the answers to these as well. So I've scanned them. So some of them are about science and some of them are not. So just short answers for you both. Keep an open mind. But the first one is an interesting one. So what was your first paper that you published as a first author, and what was it about?
Okay, I can start. 1998, it was about transcriptional regulation of the Epstein-Barr virus nuclear antigen 1 gene in lymphomas.
And which journal was it in, Henrik?
Journal of General Virology.
Okay.
Oscar?
Yes, I think it was about excitotoxicity in a mouse model of Huntington's disease. I think it was published in '99 in PNAS, if I'm not mistaken.
And this is also a fun one. I think well, you're both music fans, so I think you both enjoy this. If you could join and play with a band on a song in a song live on stage just once, which band would you be, and which song would you pick? So you're allowed to join any band in history for one song.
I know. Should I go, Oscar? Motorhead,
Yes.
Ace of Spades.
Motorhead,
Ace of Spades.
Okay. For me, it would probably be Primal Scream, maybe Higher Than the Sun.
Very nice. Very good. Okay, and then the next one. So if you weren't in science or medicine, where do you think you would have ended up? Not where you wanted to be. Where do you think you would have ended up?
Oi, oi, oi.
Yeah. I know I applied to physics at the same time as med school, and I actually wanted to work with theoretical physics more than with med school. But since I was allowed into med school, I didn't want to lose the opportunity. So I guess physics somehow.
And when I was a child, I wanted to be a garbage truck driver.
There's still hope, Henrik. You can still do it, maybe.
I'm not sure actually. I'm red green colorblind. I don't think I would qualify.
This is a nice one. So, who is your scientific or academic idol? I guess. Do you have one?
Yeah, I have one. Georg Klein. Georg Klein, he was called in Swedish. Professor of tumor biology at Karolinska, who always wrote popular science essays in parallel with his work as a tumor biologist and immunologist. And having a broad, he had such a broad and interesting view on science and society and his hardcore science, the molecular biology was doing. It plays a role in my choice of career because when I was 17, I got one of his books from my father. He had heard him on the radio, and since it was a book gift from a father to a son, I didn't read it first, but eventually I read it, and it's called The Atheist and the Holy City. It's a wonderful, wonderful book, and it is translated to English also, so it's possible to find it if anyone is interested.
I'm a bit unsure if I have one like research idol like that, but yeah, I'm very impressed by Colin Masters, for example, that have done so beautiful work and still is fantastically sharp and gives very good comments. So, yeah,
very good. So this is a very simple one. Do you have a favorite movie?
Let's see here what the English name could be. I really like a Finnish director. His name is they are actually brothers, Mika and Aki Kaurismäki, and the Life of the Bohemians. It's the name is in the real name of the movie is in French, but La Vie Bohemian or something like that. It's the movie is taking place to a large extent in Paris, but they speak a lot of Finnish in it and broken French with Finnish. I think one can find it. It's one of the most beautiful movies I've seen in the whole of my life.
I'm not sure. To be honest, I have a very short memory, so I like a lot of movies, but I don't remember the titles. So yeah.
So here's a very strategic question. Someone was very smart when they wrote this one. So they said, when you're looking to get a new PhD student or a postdoc, what's the 3 characteristics which impress you the most? Someone's looking for a job here. So any characteristics of a prospective employee that you look for in their CV or something like that?
I can say one thing, and then you can say another. So to me, the absolute most important is intrinsic motivation. So that I get a feeling that a person really loves this and really want to do it, not because of a career, but because of curiosity and so on. But that's to me is the number one most important thing.
And I couldn't agree more. I was just about to say engagement or so, but that's the same thing you are thinking of, Oscar, I think. So formal education, it doesn't really matter. I have to say that, of course, it's good if one knows something and comes with some knowledge to the team that we might need. But if someone is engaged and interested in gaining knowledge, then that is the most important thing one could think of, and has this type of driving force towards that. It really can be that's I think that's the only real trait that I feel I'm looking for all the time. It's but then of course it's important that also the person who comes likes the place they are coming to. I mean, so that one gets this type of synergism and the responsibility is on both sides somehow. So it's so I think if people are looking for a job, it's also a good idea to come and test to work in a place before making long-term commitments and so. And there are plenty of opportunities to do that also by smaller grounds and so. So it's I think it's a relatively good time to look for jobs now in the Alzheimer research field, actually.
And just a few more. So someone's really interested to know how many emails you both get a day.
Yeah.
Are we in the hundreds or are we in the thousands? Just give us a
are approaching the thousands now.
Approaching
it's
the
really,
thousands.
I am about 500 emails per day. And the spam filters work nowadays. I mean, it's emails that are, of course, they are not always something I need to act on, but there are many emails. But it has actually grown a lot the last 2 years for me. I don't know what it's like for you, Oscar. So if I don't reply, send an email again because or find my phone number.
Exactly. Yeah.
Okay, and then the final one. I think this is so. This person says, as an inspiring principal investigator, what's the biggest challenge of being the senior scientist in your lab? What's the biggest challenge that you face as being a principal investigator?
I guess to me it's because I really want to work with science. I love supervision, discussing results with PhD student, postdocs, and others in the lab. So that's what I really want to spend my time on. But so my biggest challenge is to find enough time for that and keep that and not get too much dragged into administration or a lot of other things that is not directly related to research, because that is what I really love and I want to continue doing.
My biggest struggle this autumn has been that I've been absent too much and traveling too much. I have to cut down on that, I think. But it has been really fun also. But of course, this is not fair to the people you work with closely. So it's I feel a bit bad about that this autumn, actually. But it will get better, I'm sure.
Is this a public apology to me, Henrik?
It's a big public apology to anyone I've been working with.
So I think we are running out of time, but there's two questions here that we're asked, and I want to ask them to you. So let's try and keep them brief. But the first one is about other neurodegenerative disorders. So we haven't discussed it, but our blood biomarkers, they don't really work for other tauopathies or other neurodegenerative disorders. They are specific for Alzheimer's disease pathologies. But have you seen any data or promising data published of any biomarker, whether it's imaging or CSF or skin, saliva, that may work for other tauopathies or other types of neurodegenerative disorders? Is there anything promising out there that you've seen in conferences or data that you've seen?
To me, I guess the alpha-synuclein, maybe not yet blood. I want to see that replicated a little bit more. But skin has been shown several times now, which I think is very encouraging. But also the blood, if that can be replicated, would be fantastic. I don't know, there have been some preliminary also with skin and immunoassays and so on, I think for other diseases. So that could be maybe something. Yeah, I don't know what you think, Henrik.
I agree. RT-Quick for alpha-synuclein looks really promising. It's a difficult test, of course, because when you try to do it, you spike in recombinant protein that is prone to aggregate in itself, so it's one could get false positives. But it's starting to look promising. TDP-43 has one paper where this basic technology also has been applied. Scialo et al. 2020 in brain communications. I think there is hope for that. And some other research groups are trying to do this for different tauopathies. And TMEM106B, this novel proteinopathy that we know very little about, but it seems very interesting. There might also be potential for seeded amplification of aggregates, and then we perhaps could figure out what is the clinical meaningfulness of those pathologies. Then I've been really impressed by beta-synuclein in blood, which Marcus Otto and his team have developed. I don't know if that will be by any means disease-specific or so. It's way too early to say that, but I really think one important topic for research for the future is to try to address the non-Alzheimer's neurodegenerative dementias more from fluid and imaging biomarker standpoint. Because now, as you mentioned, Oscar, if one has a very low phospho-tau concentration but still have cognitive symptoms, then one would need to think about these other neurodegenerative diseases. And then, of course, it would be helpful if there were some positive tests for them as well. Of course, neurofilament light could pinpoint a neurodegenerative aspect, but not in a disease-specific manner.
So I think that people should not be discouraged if they're young and getting into the biomarker phase, saying, "Oh, have I missed the biomarker boat?" I mean, this is such a small aspect that we've been working on, and Alzheimer's disease can encompass so many different types of. I mean, we're just tackling amyloid and tau at the moment. All the other types of proteinopathies and vascular dementia and all this. There is a lot of space to work on in terms of fluid and imaging and biomarkers.
And imagine all the non-neurodegenerative CNS diseases, the psychiatric diseases, and of course they will be very hard from a fluid biomarker standpoint, since there is no, the pathologies are not overt, but there must be a lot of interesting things in neurophysiology and imaging, and perhaps also in fluid biomarkers for those. So I would definitely be super keen to get into this field also as of now.
Okay, my final question, and it's a long question. It definitely comes from a blood biomarker skeptic. I won't list. But basically the question is: what is the biggest problem that we face getting a blood biomarker from where it is now to a routine test in the clinic? He makes, or she makes, a lot of suggestions, but I won't mention them. But how do you see it as people that work with it every day? What is the number one challenge outside of it proving itself as a diagnostic? Let's say it works well. What's the biggest thing? Is it getting physicians to trust it and what it understands? Is it actually the logistics around getting the blood test into the clinic or something else?
Yeah, so I guess briefly, I think in memory clinics that are used to using either PET or CSF, they already know how to interpret this type of results. So then I don't think it's education. I think it's more, like Henrik said, the standardization of tests that they actually work on a daily basis over time and that the cutoffs are stable. But we have seen that some assays actually fulfill that already now. So I'm, to be honest, very optimistic that, let's say, phospho-taus or certain phospho-taus can be used in memory clinics very soon in a reliable way. If you move out into the primary care, I think, besides how samples are shipped and so on, that can definitely be solved. It's probably education. So this is what we have, all of us know now, that phospho-taus are changing 5-10 years before symptom onset. It's very important for them to know, so they don't diagnose people just based on the phospho-tau result, even though maybe the patient actually has depression now and might have symptomatic Alzheimer's disease 10 years from now. So they need to know about those things and how to use the test, maybe mainly to refer people to another instance like a memory clinic for further evaluation. So it's different challenges, I guess, depending on where it will be used in the healthcare system. And it might also be very different in different countries, of course.
Yeah, and I agree with all you said, Oscar. And I was actually thinking about the last point you mentioned now, because for biotech companies and clinical chemistry diagnostic companies, they need, of course, to get some revenue. And then to be able to do that in the US, for example, they have a lot of regulatory hurdles to cross. In Sweden, again, it's easier to set up also research use only test in clinical practice, but then we do it not as the companies can't do it, but the clinical chemists can. In some other parts of Europe it is like this as well, but some parts of Europe are much more US-like. And then we have, of course, all the other, if we look into Asia and South America, and so there are also region-specific regulatory hurdles to consider, and that I believe that could be a little bit problematic, but with the advent of treatments, I think there will be forces that are strong enough to push all this forward, so that because I'm convinced the tests and the biomarkers work, and that's such a good starting point. So I am actually also very positive. If I was very skeptical 10, 15 years ago to blood tests, I'm now much more positive, and I think that these developments will go rapidly, especially if we see additional approvals of disease-modifying drugs.
Great. So I'm afraid that's all we have time for today. And if you want to know more about this topic, you can visit the Dementia Researcher website. You'll find a full transcript of the blog today and the biographies on Henrik and Oscar, and much more on the topic generally from Dementia Researcher. So I hope everyone has found this informative. I have, of course, and I really want to thank Henrik and Oscar for giving their time for us and explaining some complicated details in simpler forms. And also, we now know a little bit more that Henrik is wanting to be a garbage truck driver. Oscar wants to star as a part of Primal Screen. So we can mention that next time in our conferences when we meet together. So thanks for your time, Henrik and Oscar, and everyone for listening. Thank you.
Thank you, Nick. Thank you.
Thank you. Thank you.
Brought to you by dementiaresearcher.nihr.ac.uk in association with Alzheimer's Research UK and Alzheimer's Society, supporting early career dementia researchers across the world.